Hello, I'm Olof, and I'm about to present a project called FuseSoC. So, a few years ago, I noticed there was a need for a package manager for HCL code, because everyone was just copying code into the repositories. There was no best practices. Everyone did their own custom scripts to run a simulator and to build for a synthesis tool. And just changing the simulator was a lot of work, because everything was hand-coded. So I set up a system that could pull in your IP cores from different locations, set up a system, a complete system of them, and generate build scripts for a lot of different tools, and run simulations and run FPGA flows. And it works. And I also made sure to that so you can use them together with different flow, because I know that everyone don't want to use FuseSoC for everything. So if you want to use, for example, the Quartus GUI, yeah, you can just generate the project files and you can use the Quartus GUI from there. If you want to do your verification with vUnit, as I know some people want to do, you can just hook it up to vUnit. I have examples of that. So a few things to look at for FuseSoC that I have noticed I had to yeah, okay. The first thing is that FuseSoC is unassuming, and this means that there are no best practices in the RTL domain. Everyone doing things differently. I need to handle different kind of cores. It's not like in the software world where everything is very structured. So what I did was I created a small format to describe the core, which is called a core file, which is flexible enough to handle most of the cases. I was also tried to keep it standard compliant, so we can optionally use the IPExact. If you have IPExact files, you can parse those automatically and get your source code. It's free software, of course, but that doesn't mean that your cores have to be free software. I'm using it for myself, at my day job, for proprietary internal projects, proprietary cores. So the thing about FuseSoC, first, it manages dependencies. You no longer have to keep track of which things you need in a project. FuseSoC will know which dependencies there are between cores. It's battle proven. I have packaged a lot of stuff for FuseSoC. I think it's about 100 cores right now that I package, and the Palpino project is one of those. PCR with 32 is another one of those, and so on and so on. Lots of open risk stuff. It's extendable. I'm working on supporting more file formats, more tools, and it's not big work. I think Stefan just contributed the Vivado backend, which was about 50 to 100 lines of code. It's supposed to be modular. As I said in the beginning, you can just use part of the flow. If you just need the package management, the dependency handling, fine. Then you can use your own custom scripts for the rest of the flow. And also, you don't really need to have to do anything with the code, because these core files can either be stored together with the code, or it can be stored in a separate location, so that the core file knows where to find the code. So I have most of these cores I packaged. I hadn't had to do any changes to the cores, so you can just start using it. And of course, it exposes a coherent interface to all these EDA tools, because so just changing with simulator to use is simply flicking a command line switch. Yeah, this was very unprepared, but I'm done now. Thanks.
So I have a question about how you have built-in back-end support. Is there a way to kind of plug in extensions? So for example, say I've got a core that has some C that needs to be compiled before I can run the sim, but you kind of don't want to end up including your entire make system into FuseSoC. So like, how would I plug in like another build step that needs to happen before the sim, or like include those files in the package somehow? Is that possible?
You can do this in two ways. FuseSoC was always meant to be both a standalone application and a library. So if it's a Python, it's written in Python. So you could use it as a library from your Python stuff, or you have also the opportunity to, in the core file, specify external shell scripts to run at different parts before building a simulation model, before running the simulation, after running the simulation, after running place and route, things like that.
So I'm Dan Gesselquist. Just a real quick question. Have you thought about giving a workshop on how to use FuseSoC or how to incorporate FuseSoC into your core? I realize the people in this room are from quite a varied set of locations around the globe. It might be difficult to pull them all together, but how about an online workshop or something?
Yeah, I always thought about writing documentation. No, but the thing is, there's very little of these, and this is just a lack of time. For every release, I try to describe the new features on my blog, which is somewhere here. Yeah, to the left. So you can read about the new features, but that's about it. I would love to do a workshop, given time.
I'd love to attend.
How does it interface to code version management systems, Git and so on?
Yeah. So what you store your RTL code. You store the optionally the core file either in the same repository or somewhere else, and all the scripts are generated on the fly. All the project settings are generated on the fly. I should note also that the first thing FuseSoC does before starting at the EDA tool is that it exports all the needed files, all the build scripts to a separate location. So you can save that directory tree as a snapshot if you want to have like store a tagged release or something like that, or a tarball.
Yeah, I mean, I suppose what I was thinking is when you start copying files from one place to another, you can easily get confused about version control. Normally, you're doing diffs of a particular location versus the current tree, and when you start copying them around the place, you can easily get confused about what version you've got everywhere.
Yes, that's why they don't copy files. You should never copy files.
But didn't you just say that the tool copies all your files into a separate location?
Yeah, that's just part of the build step. That's the intermediate step. You can just stop FuseSoC there, and you will have a complete build tree that you can give to someone else who doesn't want to use FuseSoC, because you can see the FuseSoC's job is done by them. But it can also run the tools for you.
Okay, thank you, Olof.